Hello students, in this video we have 5.23 additional exercise problem of chapter 5. The question is, a sample of paramagnetic salt contains 2 into 10 raised to 24 atomic dipoles, each of dipole moment 1.5 into 10 raised to minus 23 joule per Tesla. The sample is placed under a homogeneous magnetic field of 0.64 Tesla and cooled to a temperature of 4.2 Kelvin. The degree of magnetic saturation achieved is equal to 15%. What is the total dipole moment of the sample for a magnetic field of 0.98 Tesla at temperature 2.8 Kelvin? Let us start with data collection. First, we are told that a sample of paramagnetic salt contains 2 into 10 raised to 24 atomic dipoles. Let us label it as capital N. So N is 2 into 10 raised to 24 atoms or atomic dipoles. Then we are given that each of this atom is having dipole moment of 1.5 into 10 raised to minus 23 joule per Tesla. Let us label it as small m. The sample is placed under homogeneous magnetic field of 0.64 Tesla. Let it be B1, 0.64 Tesla at temperature 4.2 Kelvin. So let 4.2 be T1. The degree of saturation achieved is 15%. Let it be small n. So small n is 15%. And what is the total dipole moment of the sample when magnetic field is 0.98 Tesla, that is B2 is 0.98 Tesla, and temperature is 2.8 Kelvin, let it be T2, and saturation magnetization, let it be M2, which is to be calculated, so question mark. Now, according to Curie's law, we know that the saturation magnetization M is directly proportional to the applied field and inversely proportional to the temperature. So if we take M1 to be proportional to B1 by T1, what is M1? Initial saturation magnetization at temperature T1 and field B1. And then M2 will be proportional to B2 by T2. So what if I take M2 by M1? I'll have B2 T1 upon B1 T2. Let it be equation 1. And let us check if we have all the quantities available. Do we have B1? Yes, we have B1 given. Do we have B2? Yes, B2 is also available. What about T1? T1 is also given 4.2 Kelvin. What about T2? T2 is also given 2.8 Kelvin. So if I want M2, what I should have is M1. M1 is not given. What is M1? M1 is the magnetization when we have 0.64 Tesla field applied at 4.2 Kelvin. So how do I find out M1? So I can say that for one atom, the dipole moment is 1.5 into 10 raised to minus 23 joule per Tesla. Then for 2 into 10 raised to 24 atoms or atomic dipoles, how much is the magnetization? So saturation magnetization will be 2 into 10 raised to 24 atoms into 1.5 into 10 raised to minus 23. Now this is the magnetization which we would have attained if all the atomic dipoles were aligned, but that is not the case. Actually 15% only are aligned. So M1 is 15% of saturation magnetization. So very first you have to find out M1. Once you find out M1, substitute in equation 1 and find out M2. That is all about 5.23. Thank you.